Hi everyone, it's Coach Fred, and so today I'm going to be going over exponential growth and decay from our short but mighty investigation today. I'd like you to start by doing the warm-up, handling these rational exponents and roots, and we'll go over those in class. But what we are going to have to be able to do is we're going to have to be able to graph and deal with exponential functions. And we actually have been studying them since before the break. And I'm hoping what you found today was that any function that is in the form y equals ab to the x power, where a is greater than 0 and b is also greater than 0, b cannot be 1, is called an exponential function with base b. Now, there's two things that actually can happen. So b has to be greater than 0 and a has to be greater than 0 in this form. But we have two different graphs that we were looking at the end of class today. One is called exponential growth, and it looks like this. And one is called exponential decay, and it looks like this. And growth and decay comes specifically from B, okay? So now if we look back at the example we were looking at, the notice and wonder we were looking at, we noticed that the B, this is a whole number bigger than 1, and this is actually a whole number, a fraction between 1 and 0. This made the model reflect over the y-axis, or decay, whereas this one made it growth. And that is actually the rule, or the model, the function. That's the way the function behaves. So when b is greater than 1, it will be exponential growth. And when b is a fraction between 0 and 1, it will be exponential decay. Now, a few of you noticed that no matter what, in the earlier examples on that investigation, it was never going to actually be able to reach 0. And so there was something on the graph that the graph didn't cross, and that's called a horizontal asymptote, okay? Horizontal asymptote. You also recognized in your investigation that that first term was your y-intercept. So 0a and 0a. These are all the key features of the graph, okay? So if we want to look at the key features of the graph, you're going to need to know the general shape. You'll want to know the y-intercept. You'll also want to be able to get an additional point. You can get any additional point by plugging an x value in, plugging in an input, and getting the associated output because it's a function, okay? The equation of the asymptote, well, it's a horizontal line, so it's going to be in the form y equals, and in this case, 0, because it's going through 0. And we'll also need to be able to tell the domain and the range. Okay, so the domain, we're allowed to plug any x into this function. There's no limits on it. So our domain would be -infinity to infinity, whereas the range, it's got to be above that asymptote. So that would be from 0 to infinity. I'm going to ask you, and we're going to talk about in class tomorrow, the end behavior, because the end behavior is a little bit different than end behavior of graphs that we've looked at already. So we'll go over that part in class. All right, let's try one. Let's try graphing one together. So here is an exponential function in the form y equals ab to the x. So the first thing I want to notice is the b term. The b is bigger than 1, so we would say this is growth. Why? Because b is greater than 1. The y-intercept, remember the y-intercept is where x is 0, so if I forgot that 3 was the y-intercept, if I let x be 0, I get 3 times 2 to the 0. 2 to the 0 you know to be 1, so that's why that term becomes the the y-intercept. So my y-intercept would be 0, 3. Now, if I want another point on the graph, well, I'm going to use a pretty easy point. I'm probably just going to put in 1. If I put in 1, that's going to give me 3 times 2, which is 6. So I have a 0.16. I could put more points in. I could put in -1. If I put in -1, I got 3 times 2 to the -1. That's going to give me 3 times a half. Oops, 3 times a half, which is 3 halves, which is 1.5. So then I have an input and an output, lots of points. All right, I'm going to graph that, but I am going to put in my equation, my asymptote. So my asymptote would be, in this case, y equals 0. I'm going to put in an xy axis. I'm going to do this right down the middle. I'm actually going to lower my x-axis to here. That's why I gave you a blank one. So there's my x-axis, my y-axis, and now I'm going to plot the points. Now I do have to know the general shape, okay? All right, so 0, 3 is my y-intercept, and 1, 6 is on the graph. I know that there is an asymptote, so a dotted line at y equals 0, and then the graph's going to get really close to that and shoot up. Kind of like that penny doubling every single day. It started to grow really, really slowly, and then eventually it just kind of shot up to that 10 million we came up with last couple weeks ago. All right, domain. Again, there's no limit on the x's, the inputs we're allowed to put in, so -infinity to infinity. My range from the asymptote up. So we would say y is greater than 0 or 0 to infinity. And that's how you graph an exponential function. Okay? All right, let's try decay. All right, so let's look at this one. Ever so slightly, the only thing I did was I gave you a fraction for b between 1 and 0. So this tells me it's decay because b is between 1 and 0. My y-intercept, 0, 3. All right, let's see what happens. I put an additional point on the graph. All right, if I put in 1, I'm going to get 1.5, but I decided to put in -1. And why did I do that? Well, because I knew it was decay. So if I put in 3 to the 1/2 to the -1 power, that's going to actually make this 3 times 2. Because we're going to flip 2 over 1 and make the power positive. So that's going to give me 6. All right, I'm going to go ahead and put in my x and my y axis. I'm going to plot my points. I'm going to actually plot all of them. 0, 3, -1, 6, 1, 1.5. Okay, I'm going to put in my asymptote of y equals 0. It didn't change. And I'm going to draw my exponential curve like that. Exponential curve. All right, again, the domain, there's no limit on what we're allowed to put into the function. And my range is going to be then from 0 to infinity. Equation of my asymptote, again, a horizontal line going through y equals 0. All right, so that's a little bit about the graph. I would like us to consider the rule of 4, but I'm going to do that in a second video, okay? So you have one more video to watch again, looking at this using the rule of 4.